Hello, math students, and welcome to our module on statistics and probability. This is lesson 3, and it is called Chance Experiments Explained Further. The goal for today we will identify the likelihood of events occurring. The question that I want you to think about during this lesson is, just as a reminder from yesterday, what is the difference between theoretical and experimental probability? All right, so we're going into the rest of some information that we need to know in order to understand probability and have success. So our things to know list is kind of long, but it's important. So I need you to get all of this down. So the thing to start out first is, remember that when you are finding the probability of events that are equally likely, we use the number of outcomes in the event divided by the number of outcomes in the total. So the key thing that I want you to remember on this one is when they are equally likely, okay? So equally likely was that, okay, on a die that we have, you have the numbers 1 through 6 on a die. So it is equally likely that you could get 1 out of 6. It is equally likely that you would get, if there was a 2 on a dice, it would be 1 out of 6. If it was a 3 on a dice, you would get 1 out of 6. If it was a 4 on a dice, you would get 1 out of 6. If it was a 5 on a dice, you would get 1 out of 6. If it was a 6 on a dice, you would get 1 out of 6. So they're all equal in order to get the same probability. The question that I want you to think about in this lesson, however, is what happens when it is not equally likely, okay? So what happens when you're finding the probability of events that are not equally likely, okay? And this, for me, it was kind of a little bit confusing for me to wrap my brain around, but when I really sat down and thought about how I was going to teach it to you, this is what I came up with. You still need to determine the probability in the exact same way. So you're going to record the outcomes of the event divided by the number of outcomes in total, just like we did up here, the number of events that happened divided by the total number of outcomes possible, okay? But you will notice that the fractional value that you get will not be equal. This is determined based on the fact that each variance does not have the exact same number. So what we're talking about is what the items that you're pulling out, they have a variance because they don't have the same amount of each one. So let me give you an example so that you can understand what variance means. For example, I have a bag of pens right here. I showed it to you yesterday. Here's the bag. I keep all of these pens in here, okay? And I use my pens to do our videos. And in this bag of pens that you see, here's my bag. In this bag of pens, I have in total 24 pens. There are 2 magentas, okay? There are 2 orange, okay? There are 3 blue. There is only 1 black. There is also only 1 gray. There is only 1 red. I have 2 yellow. I have 5 green. I have 4 purple. And I have 3 pink. Okay? So in total, 24 pens, but each color has a different number or a different amount. So that's what we're talking about, variance. So the fact that I have 1 black and yet I have 5 green, that means it's a variance because they don't have the same number of each color. All right, so the not equally likely comes into play here because each color that I have in my bag is not equally represented. So as you can see, there is already an unequal total of each color. This represents finding the probability of events that are not equally likely because each pen color is not represented equally. So this is how we address the fact that when you have a sample space, and sample space means a bag of pens or a dice, sample space is usually what your total is. When you have a sample space that does not have equal items in there, you're going to have the not equally likely probability occur. So now it's your turn. What I would like you to do, using all of this information that I gave you up here, is I would like you to find the probability of each color of pen in my bag. So I will help you set it up, but then I would like you to try to do it on your own. So the first setup that you're going to do is you're going to say, I'm going to find the probability of magenta. Okay, and you're going to tell me what that would be. I am going to find the probability of orange. Okay, I am going to find the probability of my blue. Okay, I am going to find the probability of black. Okay, I am going to find the probability of gray. I am going to find the probability of red. I am going to find the probability of yellow. I am going to find the probability of green. I am going to find the probability of purple. And lastly, I am going to find the probability of pink. Okay, that is what you are going to do, is find the probabilities of all of those, okay? And then once you figure out the probabilities of all of those, you're going to put it on the probability scale, and you are going to see which one is certain, never, not likely, equally likely, or those different variances of what they will come out as, okay? All right, kiddos, so now let's take a look back up here to our goal. Today we will identify the likelihood of events occurring. We have two different kinds. We have equally likely probability, and then we have not equally likely probability. You already understand what equally likely means, that it's fair and they all have the same amount of opportunities, or not equally likely is when it's not really as fair because you have different numbers of the colors that make it so it's not equally likely, okay? The other thing to go back to refresh, what is the difference between theoretical and experimental probability? Remember, theoretical is you having a general knowledge or a desired outcome of the probability, whereas experimental is completely based on you actually doing the experiment to see what happens, okay? All right, so hopefully you're getting a better grasp of the different types of probability that we're dealing with. We have theoretical, we have experimental, we have equally likely events, and then we have not equally likely events. And you need to keep all of those straight and know how to find them. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.